Hey, chemistry class. I wanted to run through one of the problems from Module 10, the chemistry of solutions. We're going to run through the on your own problem 10.4. Now this problem is spelled out in your book and you can reference that, but I wanted to walk through it because I'd received a question on practice problem number 3. And practice problem number 3 and on your own problem number 10.4 are very similar to one another. And so I was hoping that by running through this, it'll give you some insight onto that practice problem if you're needing the help. Now, we are given this equation, 5H2O2 plus 2 KMnO4 plus 3 H2SO4 produces 5 O2 oxygen plus 2 MnSO4 plus K2SO4 plus 8 water. So this equation that we're working with, we're also, as we go through the problem, we're given this question. If 200 milliliters of 0.750 molar H2O2 is reacted with an excess of the other reactants, how many grams of oxygen will be produced? So as my first step on a problem, I'm going to write down what I'm given and what I need. What I'm given is that I have 200 milliliters of 0.750 molar H2O2. What I need is the number of grams of oxygen that are produced by that reaction if this is my limiting reactant, because the other thing that I'm given is that I have an excess of all the other reactants. So for all practical purposes, I can disregard however much KMnO4 and H2SO4 I have. I know I've got plenty. This is going to be the limiting reactant, that H2O2. And so once I've got what I'm given and what I need, I'm going to reference that pictorial reminder that we've set up for ourselves that we use as far as stoichiometrically what we can begin from, as far as where we need to begin, where we're going. Remember, we can go from grams to moles to moles to grams. And we can come in at any point on this little chart here and get to any other point. And so looking at what I've got, I'm given milliliters and the molarity of this solution of H2O2. And that's going to enable me to start at this position, the second position, moles, right here. I can figure out the number of moles because remember, molarity is just the number of moles per liter, and I'm given the volume of that solution. So I can get the number of moles of that H2O2. I know that I'm looking for the grams of oxygen, and so this is my destination on this chart. So I need to go, it's going to be a three-step process. I need to find the number of moles of H2O2. I'm going to use that to find the number of moles of oxygen, and I'm going to use that then to find the number of grams of oxygen. And in fact, that's exactly what I've written out. I've gone through and written down my 3 steps as a visual reminder for myself of where I'm headed. And so I want to have that in front of me so that it's clear where I'm going. And so I've got my 3 steps written out, and I'm going to begin with step 1. So I'll rewrite what I'm given. I've got 200 milliliters of 0.750 molar H2O2. I'll cover this up just to clear up the look there. And so I've got this 0.750 molarity, right? That is, again, moles per liter. Well, I'm going to need to multiply that by the volume of the solution. Well, but I've got a problem. My units don't match up. 200 milliliters is not going to help me when I need the number of liters. So I'm going to multiply by 200 milliliters, but I also have to multiply by a conversion rate. Remember, my conversion rate is, if I'm looking for liters and I have milliliters, I've got 1,000 milliliters in 1 liter. And you can see I'm going to set up my ratio in such a way that the units that I don't want are going to cancel out. I've got milliliters up top here, and so I'm going to need milliliters on the bottom of this ratio over here, and so that I can get liters. But I need to set it up in such a way that the liters here cancel out the liters over here, so that all I'm left with is moles. Because remember, that's where I need to start. I need the number of moles of H2O2. And when I run this calculation out, then I come up with 0.150 moles of H2O2. Well, so that's step one. Draw a little box around it. That's first step completed. Second step is I am looking for the number of moles of oxygen. So, well, I've got the number of moles of H2O2. Right, so I've got that there. And when I have the moles of H2O2, what I'm then going to do is I'm going to refer back to my chemical equation. And what I see in my chemical equation is I have 5 moles of H2O2 in the first, in that equation. I have 5 moles of H2O2 on the reactant side, and that's producing 5 moles of oxygen on the product side. So that's going to give me a ratio, and I can say I can put that ratio with moles of H2O2 on top, or I can put it with moles of O2, moles of oxygen on top, whichever I need. It's just a relationship. So in this case, what I need is I need to have moles of H2O2 on the bottom so that those units cancel. And I need moles of oxygen on the top because that's, again, what I'm looking for. And we're going to see that 5 and that 5 actually cancel one another out. So I'm basically multiplying by 1. The only thing that changes is my units. So I'm going to end up with 0.150 moles of O2. So that completes step 2 for us. We're looking now for step 3, which is finding grams of oxygen. Well, for grams of oxygen, I'm going to need something called molar mass. And for oxygen, when we look at the periodic table, we're going to see that the molar mass of oxygen is 16.0. And when we look at molar mass, we understand that what that's telling us is there are 16.0 grams of oxygen in 1 mole of oxygen. So I can use that relationship. Now, remind myself, I'm not looking for just a single atom of oxygen. I'm actually looking for O2 in that chemical equation. So I need to make allowances for that. And so when I actually calculate out the molar mass, I'm going to see that the molar mass of oxygen is 2 times 16.0 grams per mole, or 32.0 grams per mole. So I'm going to use that relationship, and I can actually rewrite that as 32.0 grams over 1 mole. And I rewrite it in this way, again, to make my calculations a little clearer when I go to write things out. And so again, I'm going to write out my my previous amount of moles that I discovered in step 2, that 0.150 moles of O2. And I'm going to multiply by the ratio that I need. And again, I'm looking for how my units are going to cancel. So cancel out. I need moles on the bottom and grams on top. Moles are going to cancel. And I've got 0.150 times 32.0, and that is going to give me a total of 4.80 grams of oxygen. And just to recap, we looked at our chemical equation, we noted what we were given, what we needed, we looked at our little chart, a reminder for stoichiometry problems, and saw where we were going to begin and where we were going to end, which helped us write out our steps. And then we just worked the steps in order, one at a time, using the information from the previous step to help us on the next step. And came out with, again, 4.80 grams of oxygen. The practice problem number 3 is a very similar problem. You can go ahead and use this as an example, and you're going to have some different numbers to plug in. You'll have a different molar mass to calculate, but the general flow of the problem is going to be very, very similar to this one. So I hope that helps you guys out.